Hi, thank you for that introduction. It was lovely. I'll be talking to you about rewarding hackers for a safer future. I'll start off with a brief introduction. So as he said, I'm a security engineer at Google. I mostly do like red teaming, that's like penetration testing, any sort of like code reviews on specifically Google Cloud and other Google products. But then I'm also involved in this project called the Vulnerability Rewards Program, where we incentivize users of Google products, if they find any security issues or vulnerabilities, that we would pay them money for them to tell us what the vulnerability is. And we do that because there's an increasing black market for these security vulnerabilities. And this is sort of the topic that I want to address. And I also am a CTF player, if you're familiar with what that is. It's just like a hacking competition. And you do it in teams usually, so that's what I do on the weekends. But there's also a CTF going on at this conference right now. You can check me out later downstairs in the conference hall. I'll be hacking away. I'll also like to mention that all my opinions and views are my own. I am just here as a concerned Icelandic hacker who wants to change the current security landscape we have here in Iceland, because it's not the best right now. But here we will discuss some points what we can do to get better. So back to the topic at hand. So we want to reward hackers to make the future somehow safer. Now, why would we do that? I mean, so we assume that these hackers are like some criminals, right? So like they're trying to like get money off of people, like scamming, but we should just like put these people in jail, right? Like these are criminals. But I'd like to like propose the question that like not all hackers are bad. Not everyone hacks to do like evil or malicious purposes. There are a lot of people who call themselves security researchers, who like to do this sort of thing either for fun, educational purposes, to try to make companies more secure. For example, I would relate more to the latter one of being a security researcher. But this term is often confused with being a criminal, being someone who is a scammer, or like trying to steal passwords, or doing something they're not supposed to. And I'd like to bring a second point of like, anyone could really find security bugs. It's not specifically hackers who can only find these secret matrix code thing that allows them to break the internet. This can be like students, just like any computer science student who likes playing around. This could be programmers in all these different companies who knows how a lot of these backend systems work. Or it's just like security experts. Like let's say I'm a security expert at some company, and I use my bank daily. Like I would of course know certain things when I'm using my online bank, and I would think like, oh, maybe this is not the most secure way of doing things. So anyone could really find these security bugs, like even your mom. Like if she's using her online bank and she accidentally puts in some text instead of like some number when she's transferring to an account. Like let's say she wanted to transfer like 500 kronas to an account, but she accidentally put in some strings, and all of a sudden the system breaks. That should be classified as a security bug, and so your mom could actually find that too. But what should you do when you find this sort of security bug? Should you just like ignore it? Or should you tell your friends? I mean, it could be a funny security bug, like, hey, I managed to send you a negative amount of money, so I took money away from you. Like that's funny. I should tell my friends, right? No, that's probably not a good idea. Could I report it to the company? I mean, that would be like the ideal situation that, hey, I would tell the bank, hey, there might be an issue, you might want to look into that. But there's also another option. I could also sell it. Because as we mentioned before, there's a big market for vulnerabilities like these that could help certain individuals or criminal organizations to like gain money. They would pay a lot of money for this. And on the black market, these high-level vulnerabilities would go for like millions of dollars. So why would they not do that? But so this is a problem that I want to address because the current state of security in Iceland makes this choice not that trivial. Because as a security researcher who has found a vulnerability, I am not sure how companies will react to a vulnerability report. If I tell them, hey, there's a problem with your system. And they're not explicit in telling people if they want to get vulnerability reports. So you're not sure how they will react. And this is a big problem and a big uncertainty for people like me who like to disclose these kind of bugs to companies. I talked about it last year in my lecture at UTmessan, where I mentioned some of the battles that I had with companies not being so happy about me finding issues in their system. And this is something that I'd like to change. So I have this goal of trying to build a safer internet. Not an easy goal, but a goal nonetheless. And so I saw the current state that at least security landscape in Iceland was, and I was not happy with it. Even when I was teaching computer security at university, I could not say to my students with a straight face that they can go to a company and if they find a vulnerability, tell them what's wrong. I could not put them in that risk of potentially going into a long and dragged out legal battle of some company trying to keep their ego. So I would often tell my students, just if you find a security bug, ignore it. And what does that do for security on the internet? It's just going to leave a bunch of unpatched security vulnerabilities in all these big companies. And is that what we want? I would at least think not. So I'm going to tackle this problem from two different perspectives. And I'm going to give a step-to-step guide on how we actually tackle this problem from both what companies can do, and then also what you as a general internet user could do to help with this problem. Let's start with the companies. So what they could do better is be really express your interest in receiving these type of vulnerabilities. If you don't say anything, how am I, as a security researcher, supposed to know that you want to actually receive my bugs? Because if you don't, I'm not sure how you will react. You should describe how users should actually report these issues. In what kind of form do you want them to be in? What do you want to know about the vulnerability? What types of vulnerabilities would you like to see? What's the scope? What's not in scope? And also try to give the user some reason to also report. Because otherwise, they're just going to either ignore the bug, tell their friends, or just sell it on the black market. And that's not what we want. So we have to give them an incentive. Give them some reason for actually to use their precious time to write up a report and disclose the vulnerability properly to you. And also, because we're dealing with really sensitive matters, you should also provide encrypted channels for if I'm going to send a vulnerability to you, I do not want to send it through the plain text of the internet and allow any other hacker to see the vulnerability. And there are a couple of ways to achieve this. There are some open source projects which help you in actually conveying this message of your willingness to receive security vulnerability reports, and also how you would like to see them. So this is currently being standardized. This is a standard called security.txt. This is something that you would put it on your website. So for example, example.com/security.txt. So any security researcher would know to look there if they found a security vulnerability on your system. And this is just a simple text file which contains the following fields. So it's just contact information, just an email address like security@example.com. And you can also have an encryption field, if you want to link to a PGP key, so they can encrypt the message and make sure that only you get it, and not some other hackers who is trying to steal their vulnerabilities. You can also have this acknowledgement field. And this is for any person who has already found security issues on your system, and you can give them an acknowledgement. You can like credit them for what they found. You can also define a security policy. Every company should have one. But here you can define what your intentions are, like what you want to receive, what's in scope, who can report, and etc. And also, if you're interested in hiring more security people who do this sort of thing for a living, you can add a hiring field with like an email to some hiring site or hiring email. There's also a handy website called security.txt.org, and this is the organization behind the standard. And they provide you with a simple generator that generates the text file for you. You just insert your email, your link to your policy, and it creates this handy looking text file for you. And you just put this in the root of your domain, and then hackers can actually see that you're interested in receiving these reports. But here you can see that the contact is just like an email address for the security contact, PGP key, and the security policy. It doesn't have to be more complicated than this. But this, on the company side, has expressed intent of how they are going to react to security disclosures. And this is a key part. There are also other platforms and other ways you could do this. There are some public bug bounty programs. And this is often what you call this sort of thing, is a bug bounty. You actually you pay money for security bugs. But some of these big platforms are HackerOne and Bugcrowd, and of course there are a bunch more. But so these companies actually take away the struggle of trying to transfer money to some guy in Romania and stuff like that. It can be really difficult because often security researchers come from all around the world. They just do this for a living and try to find issues in your systems and try to help you improve. But what these platforms do is they take a fee. So if you're paying any rewards, they just take some flat fee. But they handle a lot of the communication with the security researcher, which can be really useful. So I would recommend looking into that. But let's say you've signed up. You either said you wanted to get bugs from the security.txt or any program. What do you do when you get a security report? So the first thing you do, you want to verify that it's an actual problem, like that the person is not just saying some random stuff to try to get some money or scare the company. So you want to try to reproduce the vulnerability. You need to like find out, okay, is this actually possible? Do the steps to reproduce the vulnerability actually make sense? And if so, you need to find the contacts in your company who are responsible for that piece of, if it's a feature or a product, you need to find out who is responsible for fixing it. And you can work towards a fix, either just by using the team who is responsible for it, or you could also work with the reporter on how to actually remediate the issue. So the security researcher should be really knowledgeable about security, so they could give you advice on what you could do to fix it properly, and not just fix that one specific case and have like all the glaring bugs still available. And then, of course, you need to reward the hacker to make it worth their time. But what types of rewards are these? So this could be anything. So it could be monetary. You could select some amount for the worst type of vulnerability that you have in your system. For example, this should probably be like remote code execution in your production machines. So you would just like select the highest amount of money that you would like to pay out for a vulnerability, and then you can just like gradually lower that for the lower vulnerabilities. And you can see ratios on what other programs have found. For example, the Google VRP, the Vulnerability Rewards Program, we figured out like how much each bug should be should be rewarded. So we know the pricing for each of the rewards, and you can help that to find your pricing. But you don't have to give them money. You can also give them acknowledgements. So hackers are often some of them are not in it for the money. It's more about trying to build some reputation. They're just trying to figure out if they can do it, can do something. They look at security as like some challenge, and they just want to prove to everyone else that they could get into some company system, and that's it. And they want some credit for that. So just putting a link to acknowledgements of saying who has found which vulnerabilities is often enough for these security researchers. And in the Google VRP, we have this thing called the Hall of Fame of everyone who's hacked Google. And a lot of researchers would happily just accept to get on the Hall of Fame and not take any money. And that's what happens. And I would highly encourage you to actually look into this, even if you don't want to pay money for these security vulnerabilities. But now moving on to the users. What the internet users can do. And I assume like all of you are internet users, seeing that you're here. But a lot of people ask me like, how do you get into security? How do you get into like finding these bugs? And it can be daunting. It can be a lot of information at the same time, and it looks like black magic. But honestly, like anyone can do it if they set the time and have the right expectations. And a lot of people ask me, like, how do you get into this bug bounty business? Like, how do I make money from just like finding security bugs online? And the first step to it is before you start looking into any company, because we are ethical hackers, we want to hack for good. We want to have some rules of engagement. So we want to make sure that we never go further than we need to. So we make sure that we just prove that there exists a vulnerability, and we don't go any further than that. We don't go to like exploiting the whole thing and like dumping the entire database of the company. That's too far. We just want to show that there is a vulnerability. So any sensitive data is out of the question. As soon as you touch any user data, that's when it becomes tricky for the company. Like if they actually should sue you because you actually got a lot of data that you should not have. So to make it easier, just never actually get that data. And also one important point is you cannot just take down the company's services. If you're always like scanning, running tools, and you just like ruin their entire system because you're trying to find bugs, that's also not good because you're disrupting their servers, they're losing money, and that could hold up in court. So make sure you're not doing any sort of like distributed attacks on the company. And of course, always respect the security policy of the company. If they say that only like this system is in scope for the vulnerability program, don't go looking into like all the other systems that they have. If they're only asking for you to find bugs in this one, respect that. And if they find out that you're looking into some other systems and they tell you to stop, stop. But now, moving on to how do you actually find these bugs. So I want to go through a list of some popular bugs that I've seen a lot of security researchers find, and actually show you some examples of what they would look like and how you yourself could actually find one. So these are some secret hacker tricks of the trade, if you will. First one is really popular. It's cross-site scripting. A lot of you have probably heard about it. But this is where you have some user input being rendered on a website, and they forget to HTML sanitize the input. So that means the user can really put anything that they want on the website, including JavaScript, any code. And if it's stored in some database, then this code would be executed for multiple users. So it used to be more popular back in the day, but now that Chrome and more browsers are getting better at fixing these vulnerabilities, it's not as big of an issue. as it was back in the day, but we still see a lot of these type of bug reports. If you wanna test this out, if you wanna like try to find the cross-scripting vulnerability, just try to add the text right there. Script alert 1, and if you see a dialog box and it says 1, that means you've found a cross-scripting vulnerability. It can't be that easy as going on some commenting website. You can like put this as the comment, and if something changed on the website, you know that you found a security vulnerability. This can be used then later to try to impersonate users. You can steal their cookies and therefore steal their accounts. But for disclosing this type of vulnerability, you would stop at just seeing the dialog box pop up. You would not go into the full exploit chain of trying to steal some accounts, because that's, again, according to the rules of engagement, that's too far. Another type of vulnerability that is really popular nowadays, and we see this a lot actually, is broken authorization. So this is where you're missing all your access control checks, especially in like APIs or that sort of systems. So the programmers tend to forget that the user has a lot of control of the request they sent, and they can pretty much change anything that they send to the server or the API. So they just assume that if they can send this request, they should have the permission to do it. That's not the case. So these checks are really important, but often looked over. So we could change some like IDs of users, projects, nodes, whatever. And if we just like try to change these IDs to something that we're not supposed to be able to change, we found broken authorization. So that's, for example, if you have some API that has like users delete, and you find the user ID field within this example 1337, what if we just change it? What if we change it to like 20 or like 30? Is the user with the ID number 20 going to be deleted? If they're not doing their access control correctly, yes. And this is really big nowadays. And I'm going to move on to one of my favorite bugs, this last one. It's the server-side request forgery. It's fairly new, at least in these bug bounty programs. So this is where you trick servers to actually send requests on a local network. Usually where the attacker is not supposed to have access to any of the internal infrastructure of the company. But with these sort of forgeries, you actually can. And this would appear when a URL is actually user provided. And this can be used to like scan the internal network, find all your like sensitive databases, or like any system that you assumed was not public. You can extract the data from those. For example, in this example, it's just like a simple post message to an API, but they specifically mention like the user API is at this URL. Okay, but what if I change it? What if I change it to the IP of your database, or like I change it to some internal system which I'm not supposed to have access to? The server is just going to send the request, and your firewall is just going to see, oh, it's the production machine. They're supposed to have access to this, so this is fine. So this is a really cool bug. I recommend looking more into that. But then you actually have to report these. And when you want to report them, you have to like summarize them. If you don't have that much technical like knowledge, you can have like an executive summary of what you can do. It brings or have some steps to reproduce the vulnerability. And these have to be detailed so anyone can reproduce it. It's better if you have a proof of concept, actually some code which does these steps. And then you also gotta explain why is there so much impact with your bug. And that helps bring some attack scenario. Explain what an attacker could do. But that's my time, so help me make the internet safer. And if you want to see me hack later, I'll be downstairs, and you can see me find bugs live. But otherwise, thank you.